Alright, this video is going to focus on for loops in relation to Turtle graphics and instances. So this is chapters 3.6 through 3.7 in the Talking Through Code textbook. So let's open PyCharm. And we're going to do chapter 3. And we have this file from a previous video that's gotten sort of bloated, so I'm going to create a new one called for loops and instances. Alright, so we've got for loops and instances. And we're just going to create our turtle setup again from scratch. So we're going to say from turtle, import screen and turtle. Screen is equal to screen, right? Creating a screen. Shelly is, or Franklin, let's do Franklin. Franklin is equal to turtle, creating a turtle. And then we're going to do screen dot exit click. So we've got our default setup, right? The bigger screen that we had from the previous videos when we first started, and we have Shelly, or Franklin. Franklin is pointing towards the right, and he is the default shape. So let's focus on drawing a square. So we're going to say draw a square. Squares are shapes that have right angles and every line is the same distance. So we're going to do Franklin.forward 100, Franklin.left 90. Right, and we had drawn a rectangle in a previous video, and so we know that once we have Franklin like this, we just need to do it 3 more times, right? Draw a line, turn towards the left to complete the entire square. So we're going to 1, 2, 3. And now Franklin draws a square and it ends up facing back towards the right where he started. This is correct code that does work. Although it is pretty redundant, right? We have these 2 lines 4 times that we literally copied and pasted. It is never an ideal solution to be copying and pasting your code around, right? If you're copying and pasting code, you have redundancies in your code, and it can be restructured or refactored to be done in a more clever way. So that's what we're about to do. We're going to refactor the code that we have. In order to do that, we have to understand how loops work. So a loop is a structure that allows us to repeat a piece of code many times. So for instance, for x in, so x is just a placeholder value here. It doesn't actually matter. In fact, a lot of times, if we don't care about the value, it's just an underscore. This is to indicate that this variable is pretty much a throwaway. Then we have to give it a list. A list is a sequence, which is a collection of information. And in this case, this list is the numbers 1, 2, 3, and 4. And as it goes, that underscore variable is going to become a 1 for the first run, a 2 for the second run, 3, and then 4 as the loop is running. Right, so this was the redundant solution. We're going to move this loop down, and now we're going to draw a square using this loop. Draw a square with a loop. So this type of loop is called a for loop. It's easy to notice, right? There's the keyword for there. So now we have to decide what goes inside the loop. So this loop is run iterates 4 times. An iteration is just a run of a loop. So this loop is going to run 4 times, 1 for each number in its list. So what do we want to happen 4 times? I think these 2 lines of code. This Franklin going forward 100 and then turning to the left 90. All right. Let's run it and check. Yeah, Franklin moved 4 times. He went forward 100 and then turned towards the left, and that happened 4 times. Exactly what we expected, right? We ended up with a square. Now let's do some customization of Franklin right before this to make him a little bit easier to see. Let's make Franklin's pin size 4. And let's make his speed 0. I don't really care about watching the animation. I just want to make sure that what I'm doing worked. It did. Great. So I pretty much always make Franklin's speed 0 whenever I'm doing Turtle Graphics stuff, unless I'm really interested in watching it run or I'm making a video. Just because it makes it easier for me to test. All right, so that underscore variable becomes 1, 2, 3, and 4. So it's called a loop variable or a target variable. And let's find a way to make use of that target variable. So for color in. And now we're going to make a list of colors for our turtle. Yellow, green, blue, purple. So I'm still trying to draw a square. But now I want the side color, the color of the pin as it moves to be different for each line. So I'm going to say Franklin.color is color. And then I'm going to do the movement again. So when we run this, let's comment this out. So now we're only drawing our colored square. So the first line was yellow, then green, then blue, then purple, which is nice, right? So now we have a more interesting square than we had before, where each line is its own colors. All right, so we've done it where we have an explicit list here. We've done it where we have an explicit list of colors that we want to use. There is another way that we could have done the for loop on line 19. Instead of doing an explicit list, we could have said for underscore in range of 4. And then do the movement again. This will run 4 times. Because range generates a list 0, 1, 2, 3. So a range of 4 makes a list that is 4 long, and its numbers start at 0 and go up to, but don't include the 4. So 0, 1, 2, 3. So let's run it and make sure. Yeah, we ended up again with a square. So we saw really only really 2 ways to make a for loop. One with an explicit list, and one where we generate the list using this range function. So how do we do interesting things with this? Why is it so important that we have loops other than reducing redundancy? We're going to try to write a loop that will draw a shape based on a number of user entered sides. So we're not going to do this anymore. So we're going to do num sides is equal to int input number of sides for polygon. So the user is going to enter a number of sides. And we've already talked about how math is important in Turtle Graphics, and this is another place where that math is going to matter. So we're going to say for underscore in range num sides. So this loop is going to run num sides times. Now, how do I know how much to go left by? Because I know that I want Franklin to go forward 100. Right, it's pretty much a given. But how do I figure out how much to turn? All right, so we know that the sum of the interior angles of any polygon is 360. These are all going to be uniform polygons. So, where the number of angles is equal to the number of sides, so I'm going to do Franklin.left 360 divided by the number of sides. That seems reasonable. Let's go. So I want you to notice that the turtle is hanging. It's waiting. The turtle hasn't moved yet because it's still waiting for user input. So anytime we have this user input and we've created the turtle above the user input, it'll open up the turtle graphics screen and then ask us for our input in the terminal in PyCharm. 6. And your hexagon. Great, let's just test it a couple more times. Let's make sure that we can draw a square. Dead, perfect. Let's see what happens when we draw octagon. Great. What if we do a septagon? Right, it's gonna keep going. So however many sides we pick, we've already done the math so that we get the proper shape. And that's another benefit of loops, right? They can run a variable number of times, including based off user input, so we can get more interesting things for our drawings than we might have otherwise. So keep that in mind, and then the math matters. Right, if I had done incorrect math here, it would not have made the shape that I wanted. So keep that in mind. We can also we'll talk more about this later, but we could have nested these loops as well. So for instance, I could have said for x in range 5. And we haven't talked about it much, but indentation does matter. How far to the right things are. This from line 33 to 37 is all inside of the for loop starting on line 32. I can tell because it's indented over one time. This is inside of the for loop for line 35. I can tell because it's indented twice, absolutely, but once relative to this for loop. So as you're going inside of these structures, you have to tab over every time. So let's see what happened now. We have told it that this outer loop is going to run 4 times. And it's going to get the number of sides, and it's going to draw those polygons. So let's see what happens. And actually, let's do this 25 times x plus 1. We did the plus 1 because x is going to start at 0. So we want to make sure that the first one actually draws. So we're going to stop this and rerun. So we're going to draw a square, then a hexagon, then an octagon, then a dodecagon. And this was our shape. They got bigger every time because our outer sides got bigger. And we got a different number of sides every time because we told it a different number of sides. We're going to look more at loop tracing as we talk about loops in a later video. But this is just an interesting example of what you can do if you have a loop inside of a loop, right? Something that repeats itself that also repeats. All right, so those are all about for loops. Now let's talk about instances. So far we have had a single instance of a turtle. And you know what? I'm going to comment that out. So before now we have had just Franklin in this example. But we can create a second turtle called Shelly. So Shelly and Franklin can both draw on the screen at the same time because they will both exist at the same time. Franklin is one instance, and then Shelly is the other. So we can do Franklin.color is Franklin's going to be green. And Franklin's pin size is going to be 7. Shelly's color is going to be pink. And her pin size is going to be 3. Can I run this? You notice it flashed it flashed green then pink, and that's because right now Shelly and Franklin are right on top of each other. But I can do something like Franklin.left 45, Shelly.right 45, and then I can move them both forward 100. So Franklin.forward 100, Shelly.forward 100. So now when I run them, I can see clearly that Franklin and Shelly are two different turtles, right? Franklin was that thick green one, and Shelly is the thinner pink one. They ended up on separate places on the screen, and this is where animation can become more interesting, right? We can move one and the other repeatedly to watch it happen. So for instance, let's say that I wanted to draw a square with both Franklin and Shelly. This is going to draw a square. And I'm going to do Franklin first, so I'm going to copy this. The sin of copy and paste once again. And then I'm immediately going to do the same thing for Shelly. So lines 19 through 23 are inside of the for loop. I can tell because they got tabbed over. Also, in an IDE like PyCharm, this little arrow that shows up will let me collapse and expand the for loop. So I can really tell that 19 through 23 are part of the for loop because they collapsed back into it. So let's see what happens when we run this. Franklin, Shelly, Franklin, Shelly, Franklin, Shelly, Franklin, Shelly, Franklin, Shelly. Right, so we really watched Franklin took his turn, and then Shelly took her turn as they went and drew these squares on the screen. So this is where the animation can become more interesting if we have, a lot of instances doing our bidding. So let's try, this is our final thing. Let's see what happens if we make an instance inside of our loop. So we're going to stop this. We're going to say for color in colors. So we're going to do yellow, green, blue, and then I think pink, because pink is more different from blue than purple was before. Franklin equals turtle. Franklin.color equals color. Then we're going to have Franklin move. And we're going to have one little thing, which is that Franklin is going to go to the left 45 degrees after. So he's not going to end up facing the same exact direction that he did before. I'm going to run it. So we watched a bunch of Franklins go forward, right? We could see each of them went a little bit differently as we went. And that was because we had all of the different Franklins. See, we watched those Franklins happen. We watched them go over and switch. So we had the 4 there. And if we fiddled with this some more, we could, have each Franklin draw its own square in its own color. Something to look out for. We can do more math, make it more complicated. Okay, that was it. The next video is going to be about void functions and arguments / parameters. So that's chapters 4.1 through 4.4.